everyone, this is Mr. Tanner, and today we're going to run through this flow chart on how to determine what type of graph that we need to use, and then we'll actually show how to make these graphs using Google Sheets. It would be a very similar process if you were using Excel or any other graphing software. So let's go ahead and get started. So for our first set of data here, it says that this set of data shows how the average temperature changes throughout the year in Fort Collins, Colorado. So let's go to our flow chart here. And it says, does your question compare two or more groups to decide if they are different? It does not. We're only looking at temperature throughout the year. Then we go down here, does your question ask how a total is proportioned? No, we're not looking at percentages at all. Does it ask if two numeric factors are related, how wind speed and pressure are related? The first one, you could think of a numeric factor if you say January is the first month of the year, February is the second month. So yes, technically here we are comparing two numerical factors. One of them just happens to be time. So does it ask about how something changes through time? Yes, it does. It looks like we are going to be making a line graph following this flow chart. So we go back, we have our data, we have the month of the year in the first column. That represents the x-axis of our graph. And then the second column, I should say the x-axis is also our independent variable. The month is the independent variable. On a line graph, if you're doing time, the x-axis, the independent variable is always time. And then the dependent variable is the temperature, because the temperature, the average high temperature, depends on the month of the year. So once you have this data, in order to graph it, you want to select all of your data set, including the titles of that data. And then you go up and you hit this button here that says Insert Chart. If your screen is a different orientation, you can always just hit Insert and then choose Chart from here as well. There's multiple ways to go about that. Highlight your data, hit Chart, and Google's pretty good about guessing the type of graph that you're going to be using. It can typically look at your data and figure it out, but if it doesn't get it right, you change the type of chart you're looking at here where it says chart type, and then you can choose from a bunch of different options, but we're going to leave it as line. And then you have to do some customizing here. So under chart style, you can change the background if you wanted to. So it's why you could change it to gray, you can change the font. One thing that's kind of nice is if you don't have a ton of different data sets, you can actually smooth out your graph. So if you notice the change there, it kind of smooths out all the data. Under chart axes and title, this is where we change the title of the graph, the y-axis label, and the x-axis label. So if I do chart title, I might change this to something like average high temperature of Fort Collins by month. So that title is descriptive. It tells us exactly what we're looking at. If I want to change any of the axes labels or add a subtitle, then I could do a horizontal axis title, and that would change this, or I could do a vertical axis title, and that would change the temperature here. So you can see once you select the title, the text changes for what it is, and you can make it bold, you can change the font color, anything like that. Under series is when you can change how your data actually appears. So I could change the color of that series. If I don't want the line to be blue, I could make it a dotted line. You can change a lot of different features about it. You could add points for each different plot on the data if you want to help students find exactly where that is. And you can even change the shape of those points, which is easier to see if you make it larger. So under series, you have a lot of options that you can add to change the way that this looks. Legend is a key, which on a line graph you don't typically need, so we're going to leave that blank. And then again, you can change how the horizontal axis is labeled, some of the font formatting, And if you really wanted to, you could add vertical counts to grid lines. Typically that's unnecessary. So once you have something like this, you have completed a line graph. All right, our next set of data. So the data in this table looks at the money earned by an ice cream shop, should be shop, as it relates to the temperature outside. So in our data, we have in our independent variable, the x-axis is the temperature outside in degrees Fahrenheit. And on the y-axis, our dependent variable is the amount of sales in US dollars. So when it was 74 degrees outside, the ice cream shop sold $600 of ice cream. So let's go back to our flow chart. Are we comparing two or more groups to decide if they are different? No, we're comparing one similar idea here, the temperature and the amount of money that you make from that temperature. It is not asking about proportions. It's just saying for this temperature, how much money did you make? So does it ask about two numeric factors? Yes, temperature is a numeric factor and money is a numeric factor, but it's not looking at how something changes through time. So instead of a line graph this time, we are going to move over to a scatter plot. So now that we know the type of graph we need, again, we select all of our data, including the column headings. Click the graph button again for insert chart. And you can see it starts as a line chart this time. Google did not guess this correctly, and that line chart looks like a mess. So instead, I'm going to do a scatter chart. And now all those lines appear as dots. And from there, you really have a lot of the same options where you have your chart axes and titles. I'm going to change the chart title to ice cream sales as a result of temperature, something like that. If you accidentally close out of that, you can just double click the graph to bring up that chart editor again, which is a nice little shortcut. But what I really want to make sure for scatter plot is under series. Doesn't matter what the color is or anything like that, but under series, I want to add a trend line. So this is really important. So a trend line kind of shows you if there's an overall trend to the data. So if there is some sort of relationship between the temperature that we're looking at and the amount of sales. And then another useful thing is to show R squared. So R squared, which you now see up here, is really just a value of how much of a relationship there is between this. So it's between 0 and 1, and R squared of 1 would mean it's perfectly mathematically related. So the temperature would be an exact representation amount of sales. It would be a perfect predictor. 0 would be there's absolutely no relationship at all between temperature and sales. And the closer to 1, the more confident we are that there's a relationship. So an R squared value of 0.9 tells us there's a very clear relationship between the temperature outside and the amount of sales that an ice cream shop can expect. If you actually want to know the slope as an equation of this line, you can also do, where is that again? Give me just a second here. As a label for that trend line, you can hit use equation. So under label, if you put use equation, it gives you the slope as an equation, which is like the slope equals m. The slope is 10.1 times your variable x minus 117. That's your y-intercept. So you can add a data label towards that trend line as well. It's not always super useful, but if you really want to know it, you can. And then the other thing to look at under series sorry, under vertical axis, because this graph is really clumped. So if you go to vertical axis, I can set a minimum value of $550 because there's no sales under that. And it just spreads the data out a little bit more so that you can see clearly. This last dot almost looks like it's off the graph, so I could double click to bring this back up, go to customize, vertical axis, and maybe I'll set the maximum value as 1,000, so all those data points, 950 might be better, so all those data points can appear on the graph. And once you've done that, you've now graphed a scatter plot with a trend line that takes up the full area of the graph. All right, our next data set here. This table evaluates what percentage of ice cream sales are from vanilla, chocolate, mint, strawberry, and pistachio. So again, we're at an ice cream shop, but this time we're looking at the proportion of sales that come from each of these 5 flavors. We're assuming this is a shop that only has these 5 flavors because these add up to 100%. Going into our data chart here, does this compare 2 different groups to decide if they are different? Nope, it's just looking at one ice cream shop here and their sales. So we go to no. Does your question ask how a total is proportioned? Yes, it does. We're looking at the proportion of sales for each type of ice cream, which means we are going to be making a pie chart. Making the graph is the same. Select our data set and the titles. Click Insert Chart. It's guessing a scatter plot here. Let's switch this to a pie chart. And you can also do a 3D pie chart if you think 3D graphs are more interesting. And then these wedges are representative of the positions. Once you have a pie chart, there's really no X or Y axis here. There's just a title. So it's gonna look a little bit different if you go into, you can turn 3D on and off too. If you go into the customize, it looks a little bit different than some of the other ones. Under pie chart, you can actually add a donut hole if you want to. You can cut out the middle. Not sure why you would do that, but you can. You can slice the labels, so you can put labels on the slices if they fit. You could put the percentage on the slices if they fit. I kind of like putting the label on there. You can change the color of each pie slice. So if I choose vanilla, I can make it, if I really wanted to, I can make it white. It's a little hard to see, but you can maybe make it gray. For chocolate, I could actually choose more of a brown. So you can then actually customize these however you want. Mint, I could do kind of a minty color. So you can go in and do all of this. You can change your chart title here. And you can also add a legend if you wanted to. So if you add a legend, it kind of takes off the offshoot. So I don't love a legend. I think it looks better when you have the labels as they were. Like this. And that's your pie chart. These are pretty easy to make. One last data set here. This graph compares the top running speed of different types of animals. Looking at our flow chart, does your question compare 2 or more groups? Yes, it literally uses the word compares the top running speed of different animals. So once you know that's a yes, you follow it over here, and we are making a bar graph. So we're looking at the top running speed of different animals. Squirrels run 20 miles per hour. Humans run 18. That's as an average. The top speed a human's ever been measured is at a little over 27 miles per hour, but the average top speed for humans is about 18. Pronghorn antelopes, like we have in the United States, are 60 miles an hour. Cheetahs are about 68, although they've never been measured over like 64. That's an estimate of their top speed. Cottontail rabbit's about 30, elk about 45, wolf 35, red fox 31, red kangaroo 35, roadrunner, the bird, can run 26 miles an hour. So we select all our data, make our insert graph, and this time it is correctly guessed that it is a bar chart. And then from there, again, you can go into customize. You can change your axes, your x-axis, the independent variable label, the y-axis label you could change. You could go into series and you can change the color of the graph if you want. You can add data labels, so on the graph you can actually see the values. If you add the data label, you could change what that label says as well. You can make a bar graph 3D as well if you want. So there's lots of ways to customize this, but we've kind of played around with the tools in here. They're pretty similar for each type of graph. So as long as you put the x-axis in the independent variable is in the first column. That represents the x-axis. The dependent variable is in the second column. As long as you set that data up, it's pretty easy to make a graph. There's one trick I'll show you in case you ever were to mess this up. So let's say I had reversed this data and I put the independent variable on the y-axis position, and then I went to graph it. It's gonna look like a mess, but if I go to under setup, switch rows and columns, then it can recorrect what we're looking at, and I can choose a column chart again, and for whatever reason it colored it differently this time. So it's better to set it up correctly the first time, but if you do make that mistake, you can always switch rows and columns to kind of fix what you're looking at. All right, hope this video helped you with making graphs, and thanks for watching.